Hi guys, today we're going to be doing pages 21 and 22, and this is solving a quadratic linear system of equations algebraically. Okay, so we know that a parabola is the graph of a quadratic. So let's just say I had these three parabolas. Okay, so here are my parabolas. And line, the graph of a linear system is a line. So let's say I have a line, goes like that. That would give me 2 points of intersection, which would be two solutions. Or let's say I have a line that goes like that and touches just once, that would give me one solution. And let's say I had a line that went like that and didn't touch it at all. That would give me no solutions. Similar to like how many roots you could have, because remember, like the x-axis is a line. So when we're looking for the roots or the zeros, we could have two, we could have one, or we could have none. Okay, so when we can solve graphically and we can solve algebraically, and today we're going to do algebraically. And then we're going to do graphically probably next week. All right. So I use substitution. Basically what I do is I put them both in y equals form and then set them equal to each other so that I'm substituting for y. So I would have x squared minus 4x plus 3 equal to half of an x plus 1. I am going to multiply everything by 2 because I am not a fan of that half. So that's 2x squared minus 8x plus 6 equals x plus 2. I'm going to set it equal to 0 in the hopes that I can factor. So 2x squared minus 9x plus 4 equals 0. Okay, so I'm going to split the linear term into minus 8x and minus 1x plus 4. I'm going to pull out a 2x from the front. I'm going to pull out a negative 1 from the front. So that gives me factors of 2x minus 1 and x minus 4, which of course are equal to 0. I'm going to set both of those equal to 0. And that's going to give me 2x equals 1, so x equals 1/2. 1/2 is the x. I need to find the y. And that gives me x equals 4. 4 is the x. I need to find the y. So I'm just going to substitute those in for x. So 1/2 squared minus 4 times 1/2 plus 3 equals 1.25. So 1 1/4 or 5/4. And then if I substitute in 4, I should have used the linear one. Here's a little advice. If you substitute in the linear one, it's a little easier. Half of 4 is 2. 2 plus 1 is 3. So those are the two solutions. So the solutions are going to be points. There's going to be an x and a y. And in this case, there are two of them. Okay, so same idea. I'm going to set these equal to each other because they're both set equal to y. I'm going to move that in the hopes that I can factor this. Oh, that should be 5. I almost subtracted wrong. Let me erase that. That would not have been good. Okay. Minus 5x equals 0. If the constant term is missing, you have to do GCF factoring. So I set those equal to 0, so x equals 0, and x minus 5 equals 0, so x equals 5. So it's 0 comma something and 5 comma something. So I'm going to this linear one here. 0 plus 2 is 2. 5 plus 2 is 7. So again, I got two solutions. So, most of the time you do get two solutions, but not always. Sometimes you get one, sometimes you get none. Right now I have those two. And you can check this. Okay. So for this one, I am going to substitute this right up there. So x squared minus the quantity 3x minus 1 equals 5. I could set them both equal to y and solve as well, but I saw that, so I decided to substitute. Distribute the negative, so the 1 becomes a positive. Set it equal to 0, and factor. Not everything is factorable, but so far so good. The nice thing about things being factorable is that means you're going to get a rational answer, and rational answers are always easier to check. Okay, so that gives me x minus 4 equals 0, so x equals 4. X plus 1 equals 0, so x equals negative 1. Okay, 4 comma, negative 1 comma. Okay, 3 times 4 is 12. 12 minus 1 is 11. Negative 1 times 3 is negative 3. Negative 3 minus 1 is negative 4. Okay. All right, one more. And then I'll show you actually a check, which would be nice. Okay, so I'm going to solve this for y. So if I move the x, that gives me negative y equals negative x minus 5. Multiplied by a negative 1, that gives me y equals x plus 5. So I'm going to substitute the x plus 5 in place of the y. All right, so I'm going to set this equal to 0. So I get x squared minus 7x. Oh, that's nice. So that's going to be easy to factor. So I get x and x minus 7. So I get x is equal to 0 and x minus 7 is equal to 0. So x is equal to 7. So 0 comma something and 7 comma something. All right, so I'm going to go right here. 0 plus 5 is 5. 7 plus 5 is 12. All right, so how do you do a check? Now you can use your graphing calculator to check, which is lovely, or you can use substitution to check. So I'm plugging stuff into y equals x squared minus 6x plus 5, and also x subtract y equals negative 5. Okay, so I'm looking for this to be true. 0 squared minus 6 times 0 plus 5. 0 minus 0 plus 5 is 5. 5 equals 5. Almost there. Okay. 0 minus 5 equals minus 5. Minus 5 equals minus 5. Yes, I'm halfway there. Good. Okay. I'm going to write the x minus 5 over here because I just don't know if I'll have enough room. Okay, so x is 7, y is 12, equals negative 5. So negative 5 equals negative 5. I'm looking so hopeful. Going to move me to the top. Whoa. Oh, that was fun. Okay, there I go. Went on a little ride. All right, so y equals x squared minus 6x plus 5. Okay, 12. I'm hoping to get 12. 7 squared minus 6 times 7 plus 5 more. Okay, 12 equals 49 minus 42 plus 5. 12 equals 49 minus 42 is 7. 7 plus 5 is 12. I did it. Check, checkaroo. You can also use your graphing calculator to help you check. Okay? Have a great day. The practice problems are optional. Optional is kind of a code word for extra credit. Okay? So maybe you want to do those. It's page 25, numbers 1 and 2, and page 26, 5 and 6. All right? Have a great day. Bye.